Here you go. Recording is started. Today is May 6, 2026. And let's start sharing the screen. Insert today, May 6, 2026, Wednesday. Get the syllabus here. That's the syllabus. We are writing here, May 6. We're gonna continue covering chapter 26, and then the first hour, right? And then we will start lab number 6, which is very similar to lab number 5 and 4. Lab number 6, the only difference is the number of resistors that is in the circuit and how they are connected. That's the only difference between lab number 6 and 5 from lab number 4. I want to point out today, and by the way, today is the 23rd meeting, the 13th week. 13th week, 23rd meeting. So I corrected lab number 3 and uploaded its correction in a PDF file. Okay, check your grade. Check your grade and the correction, right? And let me know if there is a problem. The main problem that I have been seeing here in the correction, let's see here. The main problem I am seeing in the lab reports, main problems, right, are the following. One, you need, let's start with graphs, right? Graphs. Many of you fail to label the axis with the units. Okay, that's one. Another problem that I usually see in the graphs, it's optimization of the graph space. Okay, make sure you change you adjust the axis of the graphs so the points, so you do not have too much blank space. Too much blank space. That's for the graph. I see that very consistently with many students. Now, what about significant figures, right? Significant figures. Many of you leave the numeric display. If you do not adjust the font format to get the correct number of significant figures. So make sure that you do that too. And the other one, even simpler to do and requires far less work, is the units, right? Many students do not fill the cells where you are required to display the proper unit. And that's something very simple, because all it takes is just most of the time is just copy and paste. So watch out for that. You lose lots of points when you fail to do that. And what else? Correct lab now. The homework, right? The homework. Check your grade in Canvas against your grade in Wine Plus. Okay. I just picked up a mistake that I made in the transferring of the grade, right? So make sure I just picked up a mistake of mine in the transferring of the grade of a student. And he flagged that for me. He flagged that for me. So if it happens to you, just send me an email and I'll fix that, okay? I will fix that. So lab and homework, right? Lab and homework. Let's take a look at, okay, where we stopped last time, right in here. That's, okay, so we did all of that last time, all possible configurations, right? We just didn't do this one infinitely distance from the mirror. That's the only one we didn't do. But I can tell you, let's see here. Let me just I'm going to summarize what happens to the image in all those cases. Okay, and let's get this syllabus again. Mirrors 2, where we didn't do refraction, right? So let's fix that. Refraction comes afterwards. We're doing mirrors. That's a second meeting for the mirrors. Okay, so here you go. Different object mirror configurations, right? Object at a distance, at an infinitely long distance from the mirror. Long distance from the mirror. So what happens here? The image in this specific case that I didn't show to you, but you can picture that from the equation. The image is formed at the focal point of the mirror. Okay, so if the object is a distance with a distance from the mirror that is infinitely long, infinitely distant, infinitely distant object, infinitely distant. Here you go. Let's put it this way. infinitely distant from the mirror. The image form at the focal point of the mirror. And that can be pictured either by doing that geometrical approach or by checking the equation of the mirror. Okay, this can be determined either from the geometrical procedure or directly from the equation. This is the equation here. Here you go. Object at distance infinitely long, infinitely distant. This term disappear, right? This term disappear whenever d not goes to infinity. Nope, not this one. This one here. Let's say, where's the infinite symbol here? And that's the, oh yeah, here you go. Okay. Oops. This equation reduces to the following. Here becomes 0, right? And the focal distance is going to be, and the position of the image is going to be equal to the focal distance. Here you go. Like that. And this can be determined either for the geometrical procedure that I did in class, I did in class, or directly from the equation. Okay. Past the center of curvature of the mirror, right? If the object at a sitting past the center of curvature of the mirror. And from the procedure we got, what happened? The image is formed between the focal point and the let's see that. And the center of curvature and the center of curvature of the mirror. And that again can be determined from this equation. Okay. Number 3, at the center of curvature, object sitting at the center of curvature of the mirror. At the center of curvature of the mirror. Okay. Image is formed exactly at the center of curvature. And again, this can be appreciated from the equation of the mirror, right? He goes, C here is going to be two focal point. Huh? Let me see here. I'm just gonna repeat that. D naught equal to 2 times the focal point. This equation becomes 2 times the focal point. We pass this term to the left and becomes something like that. Go another step, becomes 1 over 2 the focal point, and di is 2 times the focal point. Okay? Two different ways, the geometrical way and the equation way. And the way that, okay, between the center of curvature and focal point of the mirror. Okay, image is formed after the center of curvature of the mirror. And then again, you can verify that. It's a little bit lengthy, okay, but you can find that out from the equation. Next, at the object at the focal point of the mirror. Object at the focal point of the mirror. Image is formed at infinite. And the image is said to be improper. And again, you can see that from the equation. Right in here. Let's copy everything here. Let's see here. No, let's copy this one is better. No, let's do this one. Let's see, this one. There you go. The object is exactly equal to f, right? If it's exactly equal to f, the first term on the right side becomes 1 over f. We pass 1 over f to the left side, and we have 0 on the left side. The left side is going to be 0 only if di is very large. You go only if the di is equal to a very large number. And then I'm gonna substitute here by di, right? That's the improper image. Object, last one, located between the mirror and the focal point. What happens? Okay, image is formed behind the mirror. We can even do and it's called a virtual image. You can even come up with a table. Let's see if I have the table already prepared here. If I don't have it, I will get that from scratch. It's important to show that because the same procedure that I'm doing here applies to lenses as well. Mm-hmm. Yeah, it doesn't look like I have a table. Yeah, doesn't look like I have a table. Okay, object located between the mirror and the focal point. Image is formed behind the mirror and it's called a virtual image. And let's take a look. How do I know if it's a virtual image? It's a virtual image. Whenever di is negative, it's a real image. Whenever di is positive, okay? And you can see that image indeed is going to have a negative value. Let's do that here. Okay, like that. In this case, between the mirror and the focal point, because the objects located between the mirror and the focal point, d naught is going to be less than f. Okay? If d naught is going to be less than f, here you go. Let me put, I'm going to, here you go. I'm going to put d naught right here in the left side, okay? So you can see if t naught is less than f, it also means that 1 of d naught is greater than 1 over f. It's right like that. We invert, right? We invert the inequality. If 1 over d naught is greater than 1 over f, it means that this left side here is negative. And we conclude this side here is negative. And we conclude that 1 over d naught is also negative. Okay, which means that d naught, the di, right? Not d naught, 1 over di is also negative, which means that the I is negative. That's the only, di is negative. Di is negative. Here you go. I'm going to summarize. There are other things that I didn't mention in this summary, right? But there is more. Here you go. I'm going to object past the center of curvature. Image is formed between C and F, right? Image is said to be real. Image is real because it can be projected to a screen and the I is greater than 0. The I is greater than 0. That's how you should interpret those signs. Image is said to be real. Okay. Because it can be projected to a screen and the I greater than 0. Image is inverted. Okay? Image inverted. I'm going to show you what's the equation that tells whether the image is inverted or not. Image is smaller than the object. Image is smaller than the object. Okay. What else? Object at the center of curvature. Image is formed exactly at C. Image is said to be real, right? It's said to be real because it can be projected onto a screen. It's the case of the image of your movie screen when you go to the movie. Image is inverted just like before. Image has the same size of the object. Object between the center of curvature and C, and between the center of curvature C and the focal point. Image is formed past C, right? We don't need that. image is still real because, right? Because it can be projected and the I is greater than 0. Image is still inverted. Image is larger than the object. This is the case. This is the case. This is the case. The projection in a movie. In a movie, the image projection is the case of, this is the case of the image projection in a movie theater. The object is between the film, right, of the movie is between the center of curvature and the focal point of the optical system, and the image ends up to be larger than the object. Object at the focal point F, image is formed infinitely distant, an infinitely large distance. Image is improper. Image is in the process of becoming upright. Remember, the object was initially upside down. Now the image is in the process of becoming upright. Image is infinitely large. Object between the focal point and the center of the mirror. Image is formed behind the mirror. Image is said to be virtual. Image is upright. Image is larger than the object. And virtual, again, I'm going to emphasize that the I is less than 0. The I less than 0. What else? Which other equations do we have that do you have to worry? And I'm going also to emphasize, right? This equation here. This equation here can be derived using geometrical arguments. It's not difficult to use similar triangles. The equation, let me write it down. The equation can be easily derived using geometrical arguments. And the geometrical argument that we're talking about is that similar triangles, something that we learn in geometry, in math. Similar triangles. Okay. It's not difficult to derive it, but it's a little bit extensive. It's not difficult to derive, but it is, it is extensive. But the derivation is extensive. Okay. So that because of that, I'm not doing here. Extends. Huh? It's long. Let's put the derivation is long. For this reason, I didn't do that here. And there are another equation that you have to know. Let's see if we can get that here. We don't get that here from my notes. We get that we'll get that from the book. Oh yeah, here you go. The size of the image, and we call that H naught, HI, okay, is directly proportional to the distance of the image, DI, okay? And it's not a difficult equation to memorize either. di here. And the equation looks just like that following. It depends, of course, on the size of the object. Okay? If the position of the image is positive, you get a ratio here of the size of the object divided by the size of the image. You get this ratio here that's negative. And negative size, right? Negative size of the image means that the image is inverted, okay? That's the equation you have to memorize. It's not difficult to memorize because H naught is proportional to D naught. Just remember the negative sign there in front. And you can have some examples, right? We can have some examples, just like the examples that we saw before. Let's see. For an image, let's see, for an object, example one, right? An object. Object is infinitely distant from the mirror. What is the size of the image, right? Solution. What's the size of the image and where does the image is formed, right? And where is the image is formed? We already did that, the second part. Where is the image is formed? Where the image is formed? Let's put it this way. Where find the position of the image first, right? Find the position of the image. Find the position of the image and its size. Here you go, like that. So treat that as though as it is an example. Okay, we already did this part. This part we already did, right? So here you go. The object is fine. Here you go. Two parts. A, the position of the image. The size of the image. Size of the image. A. Okay, we already did the first part before, right? Check solution. Let me just copy the solution that we did in item 1. Yeah, in this item right here. Okay, in this item right here. Solution. Well, the image is positioned exactly at the focal point. Item A. Item B. Item B. Item B, we are going to use the other equation. We are going to use this equation right in here. Let me erase that. Like that, right? The position of the image is the focal distance, F. We want to calculate HI. That's what we want to do. want to calculate HI. So we have to invert this equation. I, even better, let's invert here this one, right? It's easier to invert this one here instead. I here, I here, H not here, not here as well. And now we solve for HI. H naught goes to the other side. HI stays on the left side. DI is going to be F, right? The image has size H naught, but we don't need to know the size of the image H naught because we do know that D naught goes to infinity. If D naught goes to infinity, D naught going to infinity. So, writing here, D naught goes to infinity. HI is going to be, and don't forget, D naught is also, oh, okay, we already put F there. Let's see. Yeah, okay, we already put F there. So what we have to do, we have to copy this one and place right in here because D naught goes to infinity. This term here is going to be 0. And the size of the image is going to be 0. It's just like a point located at the focal distance. And then you can do, you can repeat that for the other cases, okay? Repeat example 1. Repeat example 1 for the other cases we discussed above, right? And what are the other cases? D naught, let's see, A, B, right? The other cases are the following. D naught, let's see, greater than 0. No, D naught greater than 2F, less than infinity. That's the other case. That's one of the cases, right? Another one, D naught between 2F and F. Between 2F and F. D naught equal to F, lowercase f, right? D naught less than F, greater than 0. You can do that at home, doing mathematical arguments. Okay. Okay. And we are doing with concave mirrors. We are done with concave mirrors. Now let us do convex mirror. Convex mirrors is simple. It's simpler. Mathematical treatment of convex mirrors is simpler than the mathematical treatment of concave mirrors, right? The mathematical treatment of convex mirrors is simpler than the treatment of concave mirrors. We are going to do the geometrical approach, just like we did before. And you're going to see even better. Let's use that simulation so I don't have to go through that grueling procedure, right? Let's see, 2025. Is that the one that I want? 2026. Okay. One important thing. Okay, that I didn't mention. For concave mirrors, we say that its curvature is positive. What does it mean? It means that the focal distance is going to be greater than 0, okay? Remember that, concave for concave mirrors, or positive mirrors. For convex mirrors is the opposite. For convex mirrors, we say this, its curvature is negative, or the focal distance is negative, like that. And I want the link for the simulation, one of the simulations. There are a bunch of simulations out there, okay? Some I believe are better than the others. That's just one of them. The simulation that I showed to you before was a different link, wasn't that? Let's see if I can find it here. So you have more than one link to refer to. And the procedure is exactly the same one. I spent oh, here you go. That's the one. That's another link here. Two different links for the same simulation, for similar simulations, not the same, but similar simulations. Let's take a look at this one here, how it looks like. Let's see, full screen, concave mirror, see? That's the concave mirror. Okay, here you go. I can move back and forth, right? The further away is the object, the closer the image gets to the focal point. Okay, let's see, full screen. Let's see if it's gonna look better. No, doesn't look. Now, when we get right here at the center of curvature, the image sits also at the center of curvature. It has the same size. It's supposed to have the same size. As we move towards the focal point, between the center of a curvature and the focal point, the image is formed further and further away and becomes larger and larger, right? As we approach the focal point, the image is formed at an infinitely distant point. Look what's going to happen. Look to this line here, right? This line is becoming more and more parallel to this other line. This line doesn't change place, doesn't change position, right? Here's the light ray that passes through the center of a curvature. Here's the light ray that passes through the focal point. Here you go. And now when you sit exactly at the focal point, the image becomes improper. What does it mean the image becomes improper? It means that the image is in the process of inverting direction. It was initially upside down. Now, as we pass the focal point, the image is no longer upside down, it is upright. But it becomes a virtual image, which is virtual image. What does it mean? It's formed behind the mirror. Okay, that's a virtual image. Now, let's take a look. How do I get out? Here you go. Escape, right? How do I get to my negative? Let's see, choose a level. No options, no options. Choose a level. Primary. concave mirror. He has concave mirror. Doesn't have a convex mirror. Let's see if he has. Oh, yeah, he does have a convex mirror right in here. Hey, convex mirror now, full screen. Okay. Note that the focal point and the center of curvature are located behind the mirror, right? Behind the mirror. So if you were to draw this spherical surface, the center of curvature would be behind the mirror. Here's the object. And you are going to see, no matter where the position of the object, the image is going to always be formed behind the mirror. It will always be virtual, the image. Here is the light ray that passes through the focal point. Here's the light ray that passes through the center of curvature. And you could also have drawn the light rays that's incident at the center of the mirror, right? And which other one can we, let's see. Which other one? We could have done the light ray. Oh, yeah, we could have done the fourth light ray. The fourth light ray is the one that passed through the focal point, right? Right in here. He didn't illustrate that. The light ray that passed through the focal point is reflected parallel to the axis of the mirror. And notice that we have just a single solution, right? We have just, I can increase, do you see I can increase the size of the image of the object? You go, we can change the position of the object as well. Notice that we have just one answer. The image always virtual and is always smaller than the object. And that again can be seen from that same equation that you saw. Let's escape here. I will get my illustration. Mirror, AC circuit, reflection, and mirror. It is 10:30, right? We have another minutes to go. Let's see here. Okay, here is. We saw that. That's the illustration for a concave mirror. Let's take a look at the negative mirror. Yeah, that's the illustration for the negative mirror. Right? Positive mirror. The borders is in the concave direction. Negative mirror, the border is in the convex direction. So here you go. Center of curvature. And we have this other center of curvature, right? I usually like to put the other center of curvature. And I want to get this one right in here. Here you go. Focal point. Focal point in front of the mirror, focal point behind the mirror. Object, distance of the object. Ray parallel, light ray parallel to the principal axis. Must be reflected in the direction that passes through the focal point behind the mirror. Now, light ray that passes through the focal point, right? I'm gonna dash this line here. I cannot dash it. Okay, leave this way. Is reflected in that direction parallel to the axis of the mirror. The intersection of those two light rays, this light ray here and this other light ray, is where the image is formed, right? But I'm drawing a third light ray that passes through the center of curvature, reflects back, right? And here we have three light rays that intersect behind the mirror, and that's where the image is formed. Okay, oh, right in here. It's small, right? It's small, but but it's in there. And that's the distance of the image. And that's all you have to know about the negative mirror. As you can see, it is very similar. It is much simpler than the concave mirror. The convex mirror is much simpler than the concave mirror. Let's get the notes for. Mhm. Now I'm going to show you how you apply the equation for the concave mirror, for the convex mirror, how to use the equation. Let's for the convex mirror. Before we do that, let's just spell out, right? Light rays, how to draw, right? How to draw the light rays for a convex mirror. Okay, 1. Draw a figure depicting the convex mirror. 2. Draw the principal axis of the mirror in the horizontal direction, passing through the center of the mirror. I'm going to spelling out on the. Okay. Indicate the center of curvature of the mirror. Curvature of the mirror behind the mirror, right? Indicate the focal center of curvature of the mirror, C, capital C, behind the mirror. Indicate the focal point of the mirror, focal point F of the mirror, behind the mirror, behind the mirror. There are a total of 4 light rays that you may use, right? You may use to find the final image, right? However, although there are 4 light rays, you need only 2, and you may choose that. You may choose 2 of them, whichever you want, unless I tell you, whichever you want, unless I tell you otherwise. Okay? What are those light rays? You don't need, let me just simplify my drawings here. You don't need to, right? Let's make it simpler. You don't need to indicate the center of curvature and the focal point in front of the mirror. Let me make it simpler for you all. The simpler, the better, right? The less things you have to memorize. There you go. Okay, good. Mirror, principal axis, center of curvature, focal point. We don't need that because it's repeated. Center, oh, another one. Center of curvature, we don't need this one. Yep. Center of curvature, focal point, object, distance of the object, light ray parallel to the axis, and blah, 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 right? Okay. There are a total of 4 light rays that you may use to find the final image. Although there are 4 light rays, you will need only 2. Only 2 of them. 2 of them. You may choose whichever you want to use, unless I tell you otherwise. You will need only 2 of them to find the position of the image. Okay, A, light ray parallel to the principal axis of the mirror. Is diverges, right? Diverges after reflection by the mirror surface, and its tail passes through the focal point behind the mirror. All right. So that's what does it is? Is exactly this drawing that you see right in here. What? Okay, here you go. Let's see here. Yeah. What I need is another line here. I prefer to, let's see if I can. Yeah, I know how I'm gonna do that. I will copy this one. Yeah. I will copy this one and paste it. And I'm not gonna change any. I'm not gonna change the position, but I'm gonna change something else. Let's see, format. See, I'm gonna remove the arrow. And what else? I'm gonna remove the arrow and I'm gonna dash it. Yeah, that's what I need. And this one here, I must shrink, right? Once I shrink, here you go. Now I have what I want. Just adjust just a little bit. Like that. Huh. Like that. Okay. Next. I don't need that. Now I don't need this one. Okay. Now I will copy this dash one and no, I'm gonna shrink this one and paste the previous one that I copied. You go. Okay. Shrink it, paste it, shrink it, paste it, shrink it. This one is supposed to do the same, but let's let's do that just so much, right? Otherwise, we fall too behind. Here you go. Yeah. Image is formed at this point. Good. Oh, I have to do this other one. Shrink it and paste it. Shrink it and paste it. Good. Save it. Going back. Okay, light ray parallel to the principal axis diverges after reflection by the mirror surface, and its tail passes through the focal point behind the mirror. Okay. Light ray parallel to the, yeah. Light ray, let's see, next one. That's the light ray parallel to the axis. Next, light ray pointing towards the focal point behind the mirror, right? Light ray pointing towards the focal point behind the mirror reflects parallel to the principal axis of the mirror. That's what you have to remember. C. Next. Light ray pointing towards the center of curvature of the mirror, right? Is reflected on itself. Light ray pointing towards the pointing. I'm going to just copy this one and paste it, right? Pointing towards the center of curvature behind the mirror. The center of curvature behind the mirror reflects on itself. Reflects on itself. Reflects on itself. You may have a fourth light ray, right? You may also have a fourth light ray. Light ray, that which I didn't illustrate there. Light ray incident at the center of the mirror. Reflects with an angle. Reflects with the same angle with respect to the principal axis of the mirror. So there are a total of 4 light rays. The intersection, okay? The intersection of 2 of these light rays behind the mirror dictates the position of the image, okay? Which will be negative. The eye is going to be, that's how you draw. Okay, and how to use the equation for the convex mirror. Let's get the equation right in here. Okay, here you go. Okay. Okay, how do the equation for the convex mirror? Don't forget that F is going to be negative. That's what you have to do. Okay, and because F is negative, I'm going to emphasize the fact that this term is negative by putting the bar, right, around the F, because we're taking the positive of F, and I'm emphasizing here that this F here is negative. D naught is going to be positive, right? And you can find di by invert this equation. You go past d naught to the left side, you get 1 over di equal to whatever you have in there. See, we have one negative term, we have another negative term, because d naught is always greater, in this case, is going to be greater than 0. Not always, but for the sake of this course, okay? D naught may be negative for certain special cases that we're not covering here in this course, but for the sake of this course, d naught will always be greater than 0. And what this equation states? This equation states that di will be negative always. Di for the convex mirror will always be negative. Note see that, you go, negative, always. You go. For the sake of this course, the position of the object is always positive. Position of the object is always positive. Okay? We need to go for a break, right? And here you go. The position of the image will always be negative. And let's do another one. All right, there's one more equation that you have to see. Is the equation of the size of the image. This one right in here. This one right in here. For the size of the image, we have the following equation. For the size of the image, we have the following equation. Go. Because the I is always negative, let me emphasize that the I is always negative, like that. H naught over HI will always be positive. H naught over HI will always be positive. So the images will always be upright. And it's 10 o'clock a.m. We gotta have our break. 10, well, no, it's 10:51 a.m., right? 10:51 a.m. 11:06 a.m. Do you have any questions? Let's see. No questions, so let's go for our break. We will be back. When we come back, we're going to do lab number 5. Okay? So see you in 15 minutes. I'm back here. Now we are going to have, we finished chapter 25. finished chapter 25. Okay, here you go. Mirror equation, right? In the magnification equation. The magnification equation I didn't mention to you, but the magnification equation is just, this equation that you see right in here. Magnification for lowercase m, right? It should be the magnitude of this ratio, which is also the magnitude of this ratio. Okay, that's what the magnification is all about. Wait a minute. No, it's the inverse. The magnification is the inverse of these equations. Here you go. The magnification is measured with respect to the object, right? If the image is larger or smaller than the object, that's what the magnification is all about. Like that. Okay, that's all. And we are finished with section number 2, with chapter 25. You go wave, front and rays, reflection of light, formation of image by a planar mirror, plane mirror, spherical mirrors, formation by spherical mirrors, mirror equation. Okay, and let's get everything together here. All the chapters in a single place. All the chapters for exam 3 in a single place. Am I recording? I think I am, right? Yeah, I'm recording. Good. All of those are covered. 4 chapters so far for exam 3. For exam 3 so far. For exam. Now we are going to look into lab number 6. Which is 2 resistors in parallel. Okay, I'm gonna copy everything here. We did lab 4, lab 5, 2 resistors. Let's see when lab 5 is due. I need to point that out to you. Let's see, Canvas. And course. Assignments. Nope, not here. Should be here, right? Okay, lab 5. I made it due today. Do you need more time? Let me give you more time. Let me give you until Friday. Yeah. Let's see how I'm going to change that here. Edit. 2 more days. I'll give you, let's see, I'll give you until Sunday, okay? So you have the weekend to work on that. That should be, that's good, 11:59 p.m. And we got it here. And now insert page break. Let's start and I gotta get you the spreadsheets. Spreadsheets for the lab. Uh, bu- 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 I'm going to stop sharing momentarily. Remind me to turn on the sharing again, okay? I need to check something here that is confidential. That's why I'm not sharing the screen. Okay, so I did it. Yo. I'm preparing the spreadsheets for you right now. Please bear with me. Okay, now I'm going to now I can start sharing the screen again. Group 1, spreadsheet is there. Group 2, spreadsheet. Group 3, group 4, group 5, lab number 6, group 6, group 7, group 8, group 9, group 10, eleven, 12, 13, 14, 15, 16, 17, 18, 19. And so let's go back to the notes here. Lab number 6. Number 6, circuits with 2 resistors in parallel. 6. Now let's get the lab slides. Two resistors. Close that. Good. And I'm gonna share the screen of one of the labs so you can follow with me. That is one of the spreadsheets that we have out there. What you have right in here are the two resistors and the value of the two resistors measured with the multimeter. Okay, so they're slightly different. One is 1921, the other is 2352. We're going to have different resistors values for different spreadsheets, different groups. And let's go through that FAT simulation, right? Like we did before. Should be very helpful. Not this one here. FAT. Physics. Let's see, we want electricity right in here. Kit DC, that's, we can have it, can be either one, okay? FAT, here you go. So the first thing that you gotta do is to download your spreadsheet to your computer hard drive. What we are going to do, we are going to verify Ohm's law for circuit with two resistors. And what is the difference between previous lab? Lab 5, we use two resistors in series and verify Ohm's law as well. And lab 4, we also verified Ohm's law, but we use just a single resistor. That's the simplest circuit that you will ever see. Okay. So we are going to measure first we will measure, let's see, I'm going to put it here. We will measure the resistance values of the two resistors with the multimeter, the DMM. Then we will collect the voltage and current data for different supplied voltage. After doing that, we will plot V along the y-axis and I along the x-axis. We'll compare the slope of the graph with the equivalent resistance of the circuit. Okay. And the equivalent resistance, what's the equation for the equivalent resistance? The equivalent resistance of two resistors that are in parallel is the following. Here you go. 1 divided by R equivalent. Equivalent is equal to 1 divided by R1 plus 1 divided by R2. Everything else is take it out. Okay. Materials, we started equipment, right? Digital multimeter. We have an illustration of a digital multimeter that we use there at LA Harbor. Here you go. That's how it looks like. Has this exactly blue color, bluish color. And here we have the multimeter measuring the resistance value. Unfortunately, our simulation doesn't show how to do this type of measurement, of this resistance measurement. Unfortunately. Resistor 1 and 2. Two resistors. One power supply. That's the next slide is all about. Here you go. Power supply. That's the representation of the power supply. Two plates, one is smaller than the other one. The smaller plate has a negative polarity. The larger plate has positive polarity. And let's not forget, when we measure the resistances, we, log it right here in the spreadsheet. Resistor 1 and resistor 2. Okay. Here is the electric potential measurements. They are almost the same value. And here is the current measurement. We have 3 separate current measurements. I'm going to show you exactly what those current measurements are in the circuit. So what you're going to do, you're actually going to plot 3 graphs, okay? You're going to plot 3 graphs. We'll get there. I'll get there with the details. Right in here. 2 resistor, 1 power supply, 2 red cables with banana termination. Let's go back to our here you go. Power supply is the battery right in here. We're mounting our circuit. 2 red cables with banana termination. The color of the cables are used only for organizational purposes. 2 black cables with banana termination. And if you go here, right in here, red cable with banana termination, plug it into this plug in the power supply. The red cable goes to resistor 1. Resistor 1 is connected in series with, wait a minute, why in series? No, it's supposed to be in parallel. Did I get it the right one? It's like I got the wrong, yeah, I got the wrong one. Resistor in series, 2 resistor late. Here you go, resistors in parallel. Interesting. Okay, that's the right one. what I'm going to do here. Let's see what I'm going to do here. I'm using I think, okay, I'm gonna change this on the fly. Okay, because I prefer to use the multimeter, the bluish multimeter. Okay, here you go. We measure the resistors. Okay, we have to do that for the parallel. Okay, and then here we get the following: power supply, right? And we're gonna put the resistor in the proto board, just like we did before. But let's not forget that those resistors will be in parallel. So when we connect them in parallel in the proto board, they are going to look like that. Two resistors in parallel in the proto board. In the next step, we are going to connect the power supply to the resistor number 1. And let's not forget that this resistor will be in parallel with the other resistor. I'm gonna remove this guy here. Oh. Here you go. We connect them in parallel. And then I'm gonna get this one right here. There you go. The resistors in parallel. Gonna make it look nice a little bit to the right, to the left. Like that. We don't need this one anymore. We don't need this one anymore. And now we're gonna get the black cable and close my circuit right here. I can also do the, let's keep this way, let's leave this way. And when we close the circuit, the diagram becomes something like the following. Okay, becomes something like that. Now we don't need that, but I'm going to need the following. Let's see. Let's take it out. And I'm going to put the circuit together in the simulation. Here you go. Wire. Here's my red cable. I'm gonna put also a switch here so I can control the circuit. Okay, red cable is gonna go to my first resistor. Ugh. Let us close the circuit. Right? One resistor, another resistor. Why? Wire? No. The resistors here are equal, so let me change their value. Let's see here. Let's put it, yeah, like that. Two different resistors. When I close when I close the circuit, you can see the electrons moving in the circuit. Here, notice that the speed of the electrons here is higher than the speed of the electrons here, which is higher than the speed of the electrons here. There's a reason for that. Okay? There is a reason for that. Then the reason is the following. The battery alone see a resistor with a lower resistance because those two are connected in parallel. Because this resistance is lower than this other resistance, these electrons flows faster than these other electrons. That's the reason. Okay? Moving faster here because those two resistors combined has a lower resistance value than any of those two resistors. That's why the electrons are moving faster. The electrons here are moving faster than here because this resistor is lower than this other resistor. And that's the direction of flow of the electrons. But the conventional direction of the current is this one here, from the negative to the positive terminal of the battery. Okay? And what are you going to do? We already measured the resistance values of the resistors separately. And now we are going to start to measure the voltage in the circuit. Oh, let me do something else here too. I'm gonna show to you the total current on the circuit. Here you go. That's what I call the total current, the one that comes out from the battery. This is going to be the current across resistor number 1, right in here. The current across resistor number 1, and that's the notation that I'm using in the spreadsheet as well, right? Here you go, I total, I1. Let me make it smaller. 18. 18. 18. Good. And we also have the current flowing through resistor number 2. Right in here. The current number 2 flowing through resistor number 2. Going back to the spreadsheet, that's the current flowing through the resistor number 1. That's the current flowing through resistor number 2. That's the current coming out of the battery. That's the voltage in the power supply. They are all of these values here are measurements. Those three values are also measurements. I'm gonna show them how, and everything else. Oh, here is measurement too, right? Measurements. Measurement. Translated to Helvetica. Let's see, Helvetica, yeah. And I want no. Here you go. Whoa, whoa. And we have results. Results. Let's put Helvetica as well. Don't want to put the same. Here you go. I'll put this way. Here we're going to measure the voltage in three different points of the circuit. V1 is going to be in three different places of the circuit. I'm going to put this one. Let's see here. I'm going to do the following. I'm going to use this one here. I have a better drawing here for the circuit diagram. Yeah, this circuit diagram is better than the other one. Okay. Let's keep this way. I'm going to emphasize here that what you see here is exactly the same of what you see right in here, which is exactly the same of what you see right in here, which is exactly the same what you see right in here. Doesn't matter how you put together where you connect your power supply to the resistors, okay? They're exactly the same. Same, same, and same. What you're going to do, the next thing you're going to do, we're going to take voltage measurements. What you cannot do, by the way, what you cannot do is to do something like that. That you cannot do. There you go. That you cannot do. You're gonna burn out your multimeter, your power supply if you do something like that. Here you go. Another thing that you cannot do is this thing right in here. Or you're gonna burn out your power supply as well. And now we are going to bring our voltmeter. Okay, here you go. Here's my digital voltmeter. Place it right in here. And we are going to measure. Oh, we are going to measure the potential across each resistor. Okay, here go. It's going to be using I don't want that here. Almost time for our break, right? Let's go for another 10 minutes. And I'm going to get the red probe of the multimeter. I don't need that. I don't need that. And then the black probe of the multimeter. Okay. To measure the potential difference across resistor number 2. And if we draw the circuit diagram, the circuit diagram looks like the following. Looks like that. Okay. For the previous drawing, the circuit diagram looks like that. We still, in this case, we need the other one. Here you go. Send to back. Yeah. Because we have only the red cable connected in this slide, we have only this part of the multimeter connected. Once we close the circuit, right? Once we close it, we get that here, like that. Let me, delete that. That's V2. And then let's draw V1. It's going to be very similar to what you see right in here. The difference is that it's connected right in here. Let's move a little bit, right? And when we do that, that would be V1. Let's see if I can get it like that. This wire goes all the way up here. This wire goes all the way up here. Even better, I'm going to use something else here. So I don't, let me use a different circuit diagram that I have elsewhere. Right here. Better now, eh? I am erasing the current direction. Go back to here is the V2 measurement, here is the V1 measurement, and then the V total measurement is going to be connected elsewhere. I'm gonna copy that and paste like that. Okay, the V total measurement is gonna be connected here. Yeah. This other one goes all the way up here. It happens that all those three configurations are exactly the same, even though the wires are connected at different spots. They end up with the same measurement. In practice, of course, this measurement is just slightly different, just like you see here, okay? Here I get 10.084. Take a look here. You can look at their spreadsheet as well, right? Here you get 10.016, slightly smaller, not much different. It's not exactly the same. The other is 9.982. It's even small, a little bit smaller than the other. The difference are between those three measurements is negligible. And let's take our break now. Our break's gonna be right in here. Oops. Break. 11:55, right? To 12:10 p.m. Yeah, I'll see you. Any questions? Okay, I'll see you in 15 minutes. I am back here. I want to go faster, okay, in this procedure for the circuit, so we can get to the spreadsheet, which is the more important thing, okay? And what we're going to do here now, in order to measure the current in the circuit is a little bit more complicated. To measure the current, don't forget to get the negative value. We have to sweep to change the polarity, right, of the power supply, and to measure the current in this circuit, we are going to have to measure three different currents. One current is gonna be measured right in here. The other current is gonna be measured right in here. The other current is gonna be measured right in here. And I'm gonna give you the final result here, so we do not spend too much time with that. So here you go. Let's see. I'm gonna need that. Even better, let me take out everything and I just get the other one that I have here. Here you go. That's how the schematic diagram looks like. That's the total current. The total current that comes out from the battery. And how does it look like in the, it looks like the following. Here you go, it's going to be connected. Here is the resistors. I'm gonna put them aside. The positive of the power supply is connected to one of the leads, to the yellow lead of the multimeter, that this yellow lead measure the current, whereas the red one measures just the voltage. What else? What's next here? We are going to get the black here. This one is going to be connected to the resistors that are in parallel, and then we close the circuit. We close the circuit. This one is resistor 1. That's how you measure the current, the total current, which corresponds to this one here, okay? To get the current going through resistor number 1, we are going to do the following. We are going to replace we're going to reposition the multimeter, the ammeter, right? The ammeter, and it is going to be placed right in here. The only difference is this positive is going to be here, right? The negative is going to be right here. And how do we get that there? Yeah, it's going to be a little bit complicated. Let's move my multimeter here. This guy, I'm going to extend like that, so I can have enough space to place my multimeter. Let's see here. My multimeter. Let's see if I can get a better drawing here elsewhere. Okay, so okay, the way we do is the following. Let me remove this resistor first. Okay, and here you go. Oh, gotta, oops. Group everything. Good. Here you go. Yeah, like that. No, this one is gonna go here. Okay. And then right in here. Right in here. Okay. What else? This resistor must be in parallel with the R1 with one important difference. This guy here is going to be directly connected to this one right here. And let me see how we can place it at, okay, we are going to do in the following. Yeah, we're going to do the following. Here we go. We're going to need a wire just like that. Oh, a wire just like that. And this wire is, let's see who did this. Okay, I'm going to do like that. Yeah. Let's do it this way. Okay. Yeah, this way is better. Yeah, now we got it right. That's how you measure current one. Gotta close the circuit. And to measure current two, all you have to do, okay, to measure current two, all you have to do is to swap the resistor 2 with resistor 1, okay? That's all. It's the simplest way of measuring current 2. And it's possible to do that in real life. Now I'm just changing R1. I'm just swapping R1 with R2 in my circuit. This one is R1. I didn't. Yeah, this one go right in here. I don't need the others. Let me, here you go. And now we are done with measure I1 and I2. I total, I1 and I2. So what do you have to do? Now there comes the real thing that really matters, right? You are going and let me show you in the simulation as well. I didn't show you in the simulation. Let me show you. Here you go. To measure V1, you have to connect right in here. To measure V2, you have to connect your voltmeter here. To measure V total, you have to connect right in here. Those measurements are going to be very close to each other. You can check that in your spreadsheet. To measure the current, here you go. Here's going to be one current. Here's going to be one current, the largest of all. Here's going to be the other current, the second largest, 1.13, 0.9, and the smallest one, 0.23. Okay, that's how we do that. And now I want you to do the following. Plot V1 versus I total. Start with that. I'm going to copy and paste the procedure. Okay. Go to board. Yeah, you got it right here. Everything here. Here you go, the plotting. I'm doing V1 versus I1. V1 along the y-axis, I1 along the x-axis. It doesn't matter if it's V1, V2, or V total here. Here, sure, I'm asking you to do V2 versus I2. But again, doesn't matter if you plot V1 or V total here. And the same thing here. Why is that? Because V1, V2, and V total should be very close to each other. So do that. V1 along the y-axis, I1 along the x-axis. V1, I1. Insert, chart, okay? Note that I have negative values for the voltage, right? That's because I swapped the polarity. Click, right click, add trend line, display equation chart, display R square on chart. The slope should be very close to the resistance number 1. And that's what I should get here. Oh no. 1936. 1936, 1.1936. Yeah, 0.76% only. Let's see, someone has a question, right? What do I do if okay, let's, yeah, that's something I mentioned before. Let me mention again. If you have R squared equal to 1, right? You have to increase the number of decimal places here, Stefan. Okay, you have to increase the number of decimal places here. How do you do that? Click the box, right-click the box, format trend line label. Highlight format trend line label. So this pane is gonna open up in the right side. Are you following, Stefan? Okay. And instead of general, you're going to number. Go to number. Note that it automatically increased the number of decimal places to 2, right? But my number is still 1.00. Maybe yours is going to be like that as well. What do? You increase the number of decimal places. Let's see if it's 6 decimal places, we get a number different of 1. Yeah, in my case, if I increase it to 6 decimal places, I get a number different of 1. It's just a matter of increasing the number of decimal places, okay? That goes for everybody else. Don't forget, of course, I have been seeing, don't forget to label the axis. Here you go. Chart design, add chart element, axis title, primary horizontal, primary vertical. I prefer you put, let's see, right here. Yeah, primary horizontal is going to be I1. And then you put the unit between parentheses. I1 should be subscripted. And I want also to increase the font size. Many of you are not doing this, not labeling. And here I also want to increase the size and also boldface it. So it makes, increase it, let's see, to the size to 14. Let's see if it's 14, looks good. Yeah. Boldface the numbers along the axis and increase to 14. And then I have to label V1. Chart design, axis title, primary vertical. Yeah, the Excel put the access title here. That's okay to put the access title here, okay? It's okay to put the access title here. So what's the size here? 20. Let's do, should be V1. Ha, V1, V1, and I'm gonna change my font. I want to change the 20 size so we can also, italicize it as well. I prefer that those numbers have a numeric format, okay? I prefer text option. Let's see, access option, labels number right in here. Scientific, instead of scientific format, put it number format. This one you can leave in scientific format along the x-axis. That's the first graph. 1936.67 is my case, right? The second graph is V2, I2. Insert, chart, plot. Right? Add trend line, display equation chart. Okay, here's my other one. My R squared again is 1, but there is a way to display it properly, right? Don't forget to log this slope there in the last table, 2355.5, 2355.5, 0.15% only for my case. And the last graph is V. Oh, come on, man, move. The last one is V total, I total. Insert, chart, like that. Click, right click, display. Okay, and that's the slope, 1067.7. 1067.7. 12:31. We still have 20 minutes to go. Don't forget, right? Don't forget to put all the units here. Unit here, unit here, unit here. Yeah, those are all the units you have to worry about. I'm putting them all in red. I take out lots of points if you don't put the unit there, okay? And don't forget to work on the significant digits as well. But let's see how you are all doing before we get. I'm gonna cover the significant digits because you're all having difficulties with that roster. Yeah. Let's see who is here today. Today is May 6th. One, two, three, four. Insert. Download, right? Download. Oni, did you download your spreadsheet?
Yes, I did.
Okay. Did you plot your three graphs?
Yes, I did.
All the three?
Yes.
Okay. Graph 1, graph 2, and graph 3. Plot graph 1, 2, and 3. Let's see. Now it didn't. I did 3 and 2. It goes negative. Okay, all three graphs, right? 1, 2, and 3. Uh,
Yes.
okay, so let's go. Mirage is not here. Next one, Evelyn. Are you there, Evelyn? Let's see. I don't see Evelyn, right? Next one. No, Susan Acosta. I want Susan Acosta first. Hi, Susan. Are you there?
Yes, I'm here.
Okay. Did you download the spreadsheet?
Yes.
Did you plot graphs 1, 2, and 3?
Yes.
Okay. Yes, yes, and yes. The next thing that you have to do is log slopes. Did you log all the slopes?
Yes, I have.
Okay. And the percentage difference, was it small enough?
Yeah, it's a long number. It's 1.53 and it keeps going.
1.53, you said?
Yeah.
1.53%?
Mm-hmm.
Okay. What's the highest one?
The highest one was 2.05.
Okay. Yeah, it's not that high, that much high. Okay,
Okay.
good. Next one, let's see. Log the slopes. And units. Did you work on the units already?
I'm doing it right now.
Okay, working on the units right now. Let's go to Evelyn. Evelyn's not here. Cristina Balderas, not here either. Next one, Queen Castaneda. Is Queen here? Yeah, Queen is here. Okay, did you download your spreadsheet, Queen? Okay, next. Did you plot graph 1? Graph number 1. 2 out of 3 graphs plotted. Okay, so you're working on the third graph. Okay, thank you. Let's go to Isabella Cisnero. Isabella Cisnero is here. No. Next is wait a minute. Emily Serna. Emily Serna is here. No, Isabella Cisnero is not here. Next is Gabriela Edwards. I don't see Gabriela. Arwa Paris. I don't see Arwa. Princess Gate. She's here, right? Princess.
Yep, I'm here.
Did you download the spreadsheet?
Yes.
Okay. Did you plot graph number 1?
Yes, I plotted graph 1 and graph 2.
Okay, you're working on graph number 3?
Yeah.
Okay. Let's go for the next one. Let's see here. Next one is Kimberly Morales. Let's see. Kimberly Morales is not here. Let's see. Trin, are you there? Trin is not here. Next is Stefan. Stefan is here. Okay. Did you download the spreadsheet?
Yeah, I downloaded the spreadsheet, did all 3 graphs, and I'm currently working on the units.
Okay.
And I
Don't
have a
forget.
question.
Uh-huh.
For the significant figures on the power supply let's say I need 3 significant figures. 6.00, is that 3 significant figures?
Yeah, but you have to look at the documents,
Yeah,
right? For significant
yeah, I
figures.
have to look at the table. Yeah.
Okay. And did you log the slopes as well?
Yes, I did that as well.
Okay. And did you get a small enough percentage differences?
Yeah. I don't know if this is small enough. 0.6,
Oh, yeah.
0.7, and then 1.72. If those are.
Yeah, those are very small. Anything less than 5% is small. Okay.
Okay, perfect. Thank you.
Okay. So with Jeremy Landis, Jeremy is here. No, Jeremy is not here. Next, Paola. Paola is not here either. Pedro Lopez. I don't see Pedro. Next, Isabel Medina. I don't see Isabel. Arian Navidius. Okay, Arian is here, right, Arian?
I plotted the three graphs. I'm working on the units.
You're working on what?
Yeah, units.
On the units. Okay, and what about the slopes? Did you log the slopes?
Oh, I haven't done that yet.
Oh, you didn't get there yet?
Yeah.
Okay, so you're still working on the slopes and the units.
Yes.
Okay, let's go to Catherine Pettis. I don't see Catherine Pettis here. Let's see. Next, Nadia. I don't see Nadia. Next, Jason. Okay, Jason is here. Hello, Jason.
Hi, yes.
Okay, did you download the spreadsheet?
Yes, I downloaded the spreadsheet.
Plot graph number 1.
Yes, I plotted it.
1. What about 2?
I plotted that one as well.
What about 3?
I plotted that too.
Okay, did you log the slopes?
Yes, I have the log slopes.
And what's the value of the percentage difference that you're getting there?
I think I did it wrong because I'm getting 4%.
4%.
4
You're
points,
let's see.
4.38.
Okay, so let's see. Like I said, small enough should be 5%, but let me plot your graph to see if you got the correct slopes. Lab, plot data, your group number 12, right, Jeremy? Yeah. Jeremy, no, Jason. 6. Spreadsheet 12. So V1, I1, insert chart, right? You go, trend line. I'm getting 909.48 for the slope. 909. Is that what you got to? For the first.
Yes.
Okay,
Yes.
1.5%. Let's see, let's do V2 now. V2, I2. Insert chart, we go, trend line, and then 1515.4. 1515.4, 1.17. You said you got like 4% for one of them. Let's see. P total, I total. Insert. Let's see if it's this is the one they're getting a high percentage. Display 571.97. 571.97. I'm getting 2%. There's something, I plotted your graph, right?
Yeah, I selected the wrong column on accident.
Okay.
Yeah. So
Okay,
I'm gonna fix it.
V1 with I1, V2 with I2, and V total with I total, okay? That's what you have to do.
Okay.
So most like, and let's see. Oh, the units. Did you start working on the units?
The units I'm working on it.
Okay, so you're working the slopes to log the slopes, right? And the units.
Yes.
Let's go to the next one. Dana. Doesn't look like Dan is here, right? Ramon. I don't see Ramon here. Audrey. Audrey's here.
Yes, hello.
Okay, did you download the spreadsheet, Audrey?
Yeah, I completed everything.
Oh, really? And including the significant digits?
Yeah.
Okay, do you have any questions about the significant digits?
No, I think I'm good.
Okay, so you log the slopes, right? You must be having a small percentage difference. Let's say significant digits. What else? You gotta do CL as well, right? So you did CL.
I'm working on the CL and R too.
You're working on the CL. Okay. And you already did the significant digits.
Yeah.
Okay. Okay, so now next is Carlo. Carlo Gallardo. It's Carlo Gallardo. Yeah, Carlo is here. Hello, Carlo. Okay. Did you download your spreadsheet, Carlo? Yes. Okay. Plot graph 1, 2, and 3. All the 3. Did you log the slopes of each of the graphs? Yes. Did you log the units as well? Not yet. Okay, so working on that. Good. So let's see. Steve Sanchez. Is Steve Sanchez here? No. Steve Sanchez. Next is Ben Bandoy. Hi, Ben. Ben is here. Let's see. PB. I plot the graphs and got, wow, 56%, 75%. There's something wrong there, okay? So let's see what's the problem, Ben. Your group number 15. Group number 15. Let's see what the problem is. Sometimes we just plot the wrong column. Here you go. Did you plot V1 and I1, right? Did you do that, Ben? Okay, so let's see what we get here. Insert chart now. Trend line, display equation chart, display R square. I'm getting 1936.7. 1936.7. I'm getting 0.8%. Okay, for V1. So you gotta see what you did incorrectly, right? Now let's see for V2. I'm just going. I'm not gonna change it here. V2 and doesn't go for. Yeah, it doesn't allow me to drag. What a shame. Okay, so I have to do from scratch. V2 I2. I2. Insert chart. Here you go. Right click, add trend line, display. Oh, you plot the wrong graphs? Okay. 2355. Let's see. 2355. Okay, 0.13%. All right. And V total. Yeah. V total. What did you plot to get that value? Can you tell me just to have an idea? Okay, so here you go. Add trend line. Here you go. 1067. 1067. 0.9%. Yeah, you got less than 1%. Okay, so work on the graphs, get the right percentage, and you download. Let's say I'm gonna say that you're working on plot number 1. Noemi, is Noemi here? No. Next, Luis Cruz. Is Luis Cruz here? No. Janie Maldonado. I don't see Janie. Mikara? I don't see Mikara. Ryan. Chris? No. Delisha? And Juan Arellano? No. Okay, so let me point out, since you folks are having problems with the significant figures, right? Let me just repeat here. Well, let's see. Let's go for Oni first. Oni, did you log the slopes in the left table?
I'm working on the slopes.
Okay. Okay, good. So let's put that working here. Let's see. Next is Susan. Did you finish the unit, Susan?
Yes.
Okay. Are you working on the significant figures now?
Yes, right now, yes.
Do you need any help with the sig figs?
So far, no.
Are you sure? Okay.
Yeah.
Okay. So let's go for Queen. Queen, did you plot the last graph? Is Queen there? I'm not hearing from her. Okay, next. Next is Princess. Are you there, Princess?
I'm here.
Did you plot the third graph, Princess?
I did.
Okay, good. What about the slopes? Did you log the slopes in the last table?
Uh, I did log it, but I'm worried about the slope for my second graph or V2.
What is the percentage difference you're getting?
19.80.
Yeah, 19.80 is high. Let's see. Let's see. Your group number 6, right? Let me
Yeah.
get your group number 6 here. I did for group number 6. See that? 1067. I did V total 0.9%. Let's see the other ones. V1, I1. Insert chart. Okay, let's see. Trend line, display equation chart, display R square, 1936. 1936 for V1. Let's see. Yeah, 0.7%. What about V2? V2, I2. Insert chart. Let's see here. Right click, trend line, 2355. 2355. Okay, so it looks like you might have plotted the wrong graph, okay?
Mm-hmm.
You like to do that from scratch?
Yeah. Can I see how did you plot V2 real quick?
What did you say?
Can I see how you plotted V2? Because I think I might have pressed the wrong column.
Okay, V2, right? V2 is this one. Let's start from scratch. V2, right? Control, click, press the control key and highlight I2. Did you highlight V2 and I2?
Yes.
Okay, and then you must insert the graph. What's the slope you're getting for V2?
Let me see. Quick.
Huh?
Wait, I didn't do it yet. Wait. Okay, I got it now. 2355.5.
2355. Okay, yeah, 0.5.
Yeah.
Okay, so that looks good, right?
Yeah.
Which one are you having a high percentage difference?
It was the second one, V2.
Okay. The other two are small enough?
Yeah, for my V total, the percent difference I got was 0.96.
Okay, I'm getting 0.97, slightly different. That's okay. A small difference.
Okay.
It's not. Okay, so we figure out what was the problem, right? Let's see here, roster, and you logged the slopes, and now you should work in the units, right? Right, Princess?
Yes, I'm working on the units.
Okay, good. Let's go for the next. Next one is Stefan. Stefan looks like he left. Next is Arian. Arian, did you log the slopes?
No, I'm working on the sig figs. I'm finishing up the sig figs right now.
The sig figs?
Yeah.
Okay. So, need any help with this sig figs?
No, it's good. I got it. Thank you.
You know what to do, right?
Yeah.
Okay. So, Jason, did you log the slopes, Jason? Is Jason still here? Yeah, Jason is still here. Oh, Jason here. Let's see. Oh, Susan, who is that? Okay, Susan. Okay. It looks like Jason is away from his computer. Audrey. Audrey left, right? Oh no, Audrey's still here. Hi, Audrey. Did you finish the CL?
Yes, I have a question.
Yeah.
If my R is 0.999, would it be 1 minus 10 to the 7th, and then the max is 1?
Yeah. Huh? The
Okay.
maximum. Yeah, you are group number, let's see. Group number 13, right? Let's go there. Let's do that together. It's 6 more minutes to go, huh? Group 13. Which graph are you talking about? The first, the second, or the other one? V1, V2, or V total?
All of them came out like that, but we
All
could
of them.
do
Okay.
the second one is the highest.
Okay, let's do the second one, V2 and I2, right? V2 and I2. That's the thing about this, those experiments in circuits, right? You get a very high confidence level. Add trend line, display equations on chart. You should get R square equal to 1, right? But we format trend line label. Number, let's put a 6 there. Let's see what we get. 0.99, yeah. 0.999, 1, 2, 3, 4, 8, 8. We are talking about how many n's? And we got 1, 2, 3, 10. N is 10. This one here, 0.999. It's so high, right? That 4 nines, 1, 2, 3, 8, 8. 4 nines. 8, 8. And then you go to that table, the confidence level table. Where is my confidence level table? Oh, I'll have to download from, what a shame I don't have it here. But let's see, right here. We're running out of time, right? 4 more minutes. Modules. Confidence level, this one. I will download. And open the table right here, 10 data points. Right here, this line, this row, right? Our R square is greater than 0.97. Consequently, the lower limit of the CL is going to be 1 minus 10 to minus 7. And the upper limit is going to be 1, just like you said, right, Audrey?
Yes, thank you.
Welcome. 3 more minutes to go. Let's see if I can help anybody else. The major difficulty, right, that you are having is, most of you are having, is the significant figures. So you have to spend some time looking at that table on significant figures. So let's see, talk to Carlo. Carlo, are you there? Let's see, Carlo is not answering. Carlo just left. Ben, are you there? Ben left as well, huh? Okay, so 2 more minutes to go. Did you log the slope, Sonny? Okay.
Yes, I did.
Okay, did you get what the percentage difference you got for each of those slopes?
The percentage difference?
Yeah.
Okay.
The percentage difference should be right in here in those cells. F55, G55, and H55.
100.
One more minute to go. Okay, take your time there, Aoni, and it's already. Oh, wait a minute. What time is that? Oh man, I went overboard, right? I went 10 minutes after I didn't even notice that. Okay, we are in the office hours right now, and let me stop the recording here. I didn't even notice that we went above the time. Hang on, when it's